Okay, hello guys. Today I'll talk about the tree diagram. Okay, so let's move into the first part about tree diagram. So here, what is a tree diagram? Here you can find we're just like doing multiple choices, or here are multiple steps for us to reach into a goal. Okay, so like here we have to throw two times of the coins. Okay, so maybe we have four situations. Like first is head and head. First is head, and then second throw is tail. Second throw is head, and first throw is tail. Second throw is a tail. Right? Okay. That is introduction to the tree diagrams. I'll just show you that. So you can find here each multiple choices is like a branch, like a half for the head and a half for the tail. Another half for head, another half for the tail. Okay, that is it. So we can say here, if you want to calculate the exact probability of the two head, so we can say the probability here using the independent event equation that is for 1/4, right? So the first time is a head and second time is a tail because the probability here is a half times another a half equals to 1/4. And one is tail, another is head, because the probability here is a half times a half equals to 1/4, okay? So the first time is tail, the second time is also a tail because the probability here is for a half times a half equals to 1/4, right? So you can find here, total possibility equals to 1, right? 1/4, then added together, that is for 1, okay? That is introduction to the tree diagrams right here, okay? So we can also like using the tree diagram to solve some problems. Like here, we said a bag has 3 red and 2 blue marbles, right? And a marble is drawn and replaced, and another is drawn. Okay. So here we can say maybe for right now, so like a red, and the second is also red because here the probability equals to 3/5 over and then times 3/5, right? Okay. So the total possibility here equals to 9/25, okay? And one is red, second is blue. We said the probability here is for 3/5 times 2/5 equals to 6/25, okay? So one blue, second red is for 6/25, and one blue, another is blue is for 4/25, okay? That is a possibility right here because here, total possibilities when you add them together is also for 1, right? Okay, so total value equals to 1. So that is it. And you can find here, if you want to find the probability to getting two marbles at the same color, we can say, see the graph, the probability for red, red, probability for blue, blue, the total possibility is for 9/25 plus 4/25, right? Okay, that is for 13/25, okay? And for the second part, for 1 minus the probability for blue blue is 1 minus 4/25 is 21/25, okay? That is how to calculate the results and adding them together, okay? That is it. So let's move to the next part. So we can say we have the tree diagram without any replacement, okay? So for example, like here, we have 3 red and 2 blue marbles, and now we draw without replacement. So first, when you draw the red, probability here is 3 over total marble 5, right? So the probability here is for 3/5, right? And when you draw blue, you can say the probability here is for 2/5, right? Okay? And after you draw one red or one blue, we can say there's 4 marbles left, right? So here we have, for this situation is 2 red and 2 blue, right? So when you draw red, it's for 2/4. When you draw blue, it's also for 2/4, right? Using the number of the marbles over total number of marbles, right? Okay, so here is for 3/5 times 2/4, okay? And here is also for 3/5 times 2/4, okay? So we'll find the two possibility right here. And for the blue marbles here and the red marbles here, we can say first we are using 2/5 times 3/4 equals to 2/5 times 3/5. And here is for 2/5 times 1/4, okay? So that is how to calculate the exactly probability right here, okay? And here are some deliberate practice for you, how you can try to understand how to calculate the exact value right here, okay? So if you want to just try on yourself, you can pause the video and then do it yourself. But if you want to follow with me, you can keep on going, okay? So maybe to the first problem, we said a box contains 5 green apples and 3 red apples, right? So the apple is taken at random, eaten, so it means not replaced, right? And then a second apple is taken. So yeah, so when you first draw the apples like here, okay, when you first draw apples like here, when you draw a green apple and a red apple, the probability here is for 5/8, right? Here the probability equals to 3/8. So the second time when you draw another apple, because it's also for green and red, so now we have 7 apples left, right? So the green apples here, we only have 4 green and 3 red. So possibility here equals to 4/7. And the red apples possibility here equals to 3/7, right? So also another situation for red, we said there's only 7 apples left, but also we have 5 green and 2 red, okay? So here for green is for 5/7, and for red is for 2/7, okay? So the first situation asking us draw a fully labeled tree diagram. So now we draw it, okay? So second is calculate the probability that both apples are red, okay? So both red here, you can just try to find here, red, red, okay? So the possibility here equals to 3/8 times 2/7, okay? 3/8 times 2/7. So you can calculate as 1/4, that is for 3/28, okay? That is it. And for another situations like here, we can set the calculate the probability of picking exactly 1 green apple, right? So here for green is for green red here and for red green here, okay? Possibility is 5/8 times 3/7 plus 3/8 times the 5/7, okay? So you can calculate it as here the numerator here is for 15 plus 15 30, right? 30/58, 56, you can divide it by 2 at the 2 side, okay? That is 15/28, okay? That is it. And for second problem, you can set here the probability it rains is 0.4, it rains the probability bus is late as 0.7, okay? So it doesn't rain, the bus is late for 0.2. So draw the triogram, find the overall probability the bus is late, okay? So because first we have the rain is for 0.4, right? So not rain for 0.6, right? And then because when the rain, the probability for late is for 0.7, and for at the time is for 0.3, right? So lot rain, we also have late. Late is 0.2, and at the time is for 0.8, right? So we want to find the probability that bus is late. So it's first is the rain, and here's late. So it's 0.4 times 0.7. And another is 0.6 times 0.2, right? That is for 0.28 plus 0.12, okay? So finally, the probability is for 0.4, okay? Which means that there are 40% possibility for the bus to arrive late, okay? So that was our lesson. Hope you can try to understand how to calculate the possibility and how to draw the tree diagram. They are very important for you to master and understand for such problems, okay? So that was our lesson. See you next time. Bye.